In a previous episode, I covered the Apple I, Steve Wozniak's home-built computer that saw some early commercial success in 1976. And in this episode, I'm going to cover the Apple II, which came out 1 year later. Now, there's a whole story to tell about how all this transpired, which I'm not going to tell in this video. It's been covered ad nauseum in other documentaries, movies, and even YouTube videos. There's even some controversy as to how or when all of these things took place, some even contradicting Steve Wozniak's version of events. So I think it's safe to say that regardless of how I would portray this, it would probably just start a flame war, and that's just not something I want to find myself in the middle of. So let's just talk about the parts that are not usually covered in these documentaries, which is, how does the Apple II actually work? When the Apple II landed at the West Coast Computer Fair in 1977, it was facing competition from two other home computers, the Commodore PET and Radio Shack's TRS-80. Byte magazine referred to this as the 1977 Trinity, as these three computers represented a major shift, finally making personal computers affordable and attainable by individuals or small businesses. Now, before we get too deep into the details, I'd like to talk about a little retrospective here. First, let's talk about Byte magazine. The internet is full of quotes talking about how Byte magazine coined the term the 1977 Trinity, but I painstakingly browsed through all 12 issues of Byte magazine from the year 1977 and saw no such quote anywhere. The only reference I can find is from a 1995 issue of the publication, which is a 20-year retrospective, and they do at that point use the term when talking about the Commodore PET. If they use the term any earlier than that, I haven't been able to find it. And now, let's talk about a little more personal anecdote. This is my yearbook from 7th grade, and this is really the only pictures I have from my junior high, especially anything showing the school's computers. Here's a picture of one of our classrooms full of Apple II computers. Some of them had green monochrome monitors, while the two on the left had color monitors. And here's another student using an Apple IIe with a monochrome monitor. Oh, and look, there's me, age 12, playing the vibraphone. See, I had a full head of hair back then. And here's another picture of some Apple IIs in a classroom, and here's even some of the office staff using one for actual official school functions. Okay, now the thing is, this was 1988. I had been using Commodore computers for about 7 years, and at this point I had a Commodore 128 at home, and had even seen Amiga computers being demonstrated in electronics stores. My 12-year-old self was very underwhelmed with the capabilities of these Apple II computers, with their green monochrome graphics and their, beeps and clicks for sounds. And while I'd never seen an Apple II for sale in a retail store, I had seen them advertised in magazines, and I saw the price. And I knew that they were pretty expensive and simply couldn't understand why. Like, why would my school have bought these expensive Apple IIs when they could have bought an Amiga 500 for half the price? So I spent a lot of my time in junior high preaching to the other kids, proselytizing my view that Commodore was way better than these Apple computers, or as me and my friends used to call them back in the time, crapple computers. So I would be explaining to them why Commodore computers were so much better. And technically speaking, I wasn't wrong from a perspective of comparing the two computers and their capabilities. But there were two glaring errors that I didn't actually understand at the time. The first being that it's very likely that my school didn't pay anywhere near those retail prices for their Apple IIs, and we'll circle back around to that again in a little bit. The other thing that my 12-year-old self didn't understand is that, when a school buys office equipment, which is, what a computer would be considered, they tend to keep it for a really long time. And so those Apple computers that we were using in school, some of them were 10 years old at that time. In fact, the Commodore 128 that I was so proud of had come out in 1985. And the Apple IIs that we were using in school, that technology had come out 8 years earlier. So I think it's important to go back to 1977 and look at the Apple II from the perspective of people at that time. And while the price was certainly higher than that of its competition, it's worth noting that the Apple II had a lot to offer. All three machines came with some form of BASIC, all three machines came with 4K standard RAM, but the Apple II was the only one to offer bitmap graphics, color of any sort, sound of any sort, or any expansion slots. Taking a look at this ad from 1977, one thing that might surprise you is that the Apple II was also available in board-only form for the do-it-yourself hobbyist. I'm not quite sure how long this offer was available though. Okay, so I don't actually have an original Apple II to show you, as they're really hard to find. And even after VCF, I was invited to the secret warehouse where there were an untold number of Apple II systems on the shelf, but none of these were an original Apple II. They were all later models like the II Plus or the IIe. However, shortly after I left, they did acquire an original Apple II and sent me this footage of it. So what I do have is an Apple II Plus, which is almost the same computer but has upgraded RAM and ROM and a slightly different badge that says Plus on it. Now, one other noticeable difference is the power light. As you can see here on the Plus, it's recessed down into the case. But if you look at the original model, the power light sticks up almost like a regular key on the keyboard. Also, even this model here isn't quite the original. That's because the first ever Apple IIs to come off the production line had no vents on the side like this. These are nearly impossible to find because Apple realized quickly that the computers were overheating, so the vents had to be added, and I believe they even offered to swap out cases for existing users. Now, one possible reason why the original models are so hard to find is that Apple also sold upgrade kits to convert your Apple II into a II Plus. So it's possible that many of the II Plus systems that you find may have originally been a base model too. There were a few other minor differences between the original and the II Plus, such as the original board only supported 4 colors in high-res mode, where later boards supported 6. Also, the original boards did not have a color killer for text mode. I'll explain more about both of these later. The last 2 upgrades weren't necessarily exclusive to the Plus, but rather by the time the II Plus came out, these features were already standard. So, taking a look at the Apple II, other than power, the only actual ports you get on the back by default is the in and out for the cassette recorder and a composite video output. There is a game port for joystick or paddles, but it's actually a dip socket located on the actual motherboard. The keyboard layout is somewhat irritating for modern people to use because the return key is in a weird place. The plus symbol is where you'd expect the colon to be, and there are only left and right cursor keys, no up and down. And worst of all, there's no backspace or delete key. Instead, the reset key is where you'd expect that to be. Now, as annoying as this is, let's be objective about this for a moment by looking at its 2 competitors. The TRS-80 had a keyboard arrangement that was equally bad, and the Commodore PET had a much worse keyboard than the Apple II. And to be fair, these keyboard layouts would not have seemed weird to the people using them at the time, because computers were brand new and thus nobody would have had any preconceived biases about how a keyboard should be arranged. Let's talk about Apple II graphics and color. First of all, text mode on the Apple II is monochrome. There is no way to change the color of the text or the background. It's simply a 40 by 24 character display, and that's all there is to it, which is fine because the reality is, back in 1977, there weren't a lot of computer monitors available for consumers to buy, and Apple wasn't manufacturing one of their own yet, so the most common monitor for people to use with their Apple II was, in fact, a CCTV security camera monitor like this. You'll see picture after picture of early Apple II setups using this sort of monitor, and these were almost always monochrome monitors. Another option would be something like this AMDEC color monitor, which was available at the time. It simply displays a color composite video signal, and while this monitor is borderline too large to sit on top of the computer, it was common to just put the television or monitor next to the computer in cases like this as well. Also, the 1980s brought us the computer hutch, which also could eliminate this problem by having a special shelf just for the monitor. Of course, in text mode, it's still going to be monochrome text. So, if you had your original Apple II with 4K of RAM, what sort of graphics would you be able to do? Well, let's start with the low-res graphics mode. And low-res is no exaggeration. You literally get 40 by 48 pixels, but you do get 16 colors, something nearly unheard of at the time. Now, I say 16 colors, it's really more like 15 because there are 2 identical shades of gray. Steve Wozniak demonstrated the low-res graphics mode by writing a version of Breakout in BASIC, which you can see running here. Now, one big advantage of low-res mode, besides the nice color, is that it was really fast to manipulate, even in BASIC, so it was possible for home users to actually write little action or Pong-style games in BASIC, and they could actually run at a decent speed. You could initialize low-res mode simply by typing GR at the command line, In this mode, you'll only get 40 by 40 pixels and 4 lines of text at the bottom, sort of a split screen. Now, this mode was handy because otherwise it wouldn't be possible to display any text at the same time as your graphics due to the size of the pixels. There were some actual commercial games that made use of low-res mode, such as the 3 Mile Island, which was a nuclear reactor simulator, and another one was Polywog. Oh, and here's another one called Firebug. Okay, so what about high-res graphics? Well, here's where we run into a problem. Technically speaking, the original Apple II has the needed hardware to display high-res graphics, but what it lacks is the needed RAM. Let's take a look at the memory layout of the Apple II. You'll find 12K of ROM at the top address space. Next to that is I/O space. Over here, you'll find the screen RAM area for high-res graphics. But if you only have 4K of RAM, then you can see the problem. There's no RAM available for high-res graphics. In fact, even doubling it to 8K isn't enough. You'll have to expand the RAM all the way up to 16K in order to be able to use it. That extra 12K of RAM would set you back around $400 in 1977. And if you want to be able to make use of the second page of high-res for double buffering, then you'll need at least 20K of RAM. On the bright side, Apple II systems were designed to be upgradable by adding more RAM, all the way up to 48K. They even left empty sockets for you to do this. This is in contrast to Commodore, who actually went out of their way to make it hard to upgrade the PET by drilling holes in the PCB where the extra RAM would go. Okay, so let's say that you have enough RAM for a high-res screen. Now I have to explain to you how Apple II graphics work, and that is a challenge. It's one of the most quirky systems I've ever seen. One issue is from a perspective of RAM, like the memory layout is bizarre. And so it requires a lot of extra complex math in order to figure out like where a specific pixel would lie in memory, which is more work for the coder, but is also more work for the computer when it comes to displaying graphics, meaning the graphics display is somewhat slower than other systems that came later. But the best way I can describe Apple II graphics is that the graphics behave completely different depending on whether you're connected to a monochrome or a color monitor. It's easiest to start with the monochrome monitor, as this is pretty easy to understand. In this mode, you get 280 by 192 monochrome bitmap, and there are no shades of gray. Pixels are either on or they're off. Unfortunately, in memory, each 8 bits only corresponds to 7 pixels on the screen. So you have to keep that in mind when programming, and there's literally an empty bit every byte of video RAM, but otherwise, the Apple's monochrome graphics were pretty easy to understand, and in 1977 was in and of itself pretty amazing. Now, I'm showing games here that obviously didn't appear until years later in the computer's life cycle, but the reality is when most people picked up their first Apple II computer in 1977, the only graphics they would see would be whatever they programmed themselves in BASIC or typed in from a magazine, as there weren't really any graphical commercial games yet for any personal computer. Okay, so now it's time to talk about Apple II color graphics. Now, the first thing I have to mention is that the Apple II did not have a dedicated graphics chip like later computers would have. So when Steve Wozniak designed it, he had to use off-the-shelf parts to come up with some kind of graphics system. And what he came up with was actually fairly innovative. It's kind of complicated to explain how artifact colors work, and it's probably beyond the scope of this video. So instead, what I'm going to do is explain from a programmer or artist perspective how you would create color on an Apple II. When a color monitor is attached to an Apple II, text mode stays monochrome due to something called the color killer, which basically disables the color burst signal when text mode is active. Although this is one of those differences I talked about earlier with the original Apple II, it lacked the color killer circuit. As such, your text would always appear rainbow colored on a color monitor, even in text mode. But in graphics mode, color is generated by the placement of pixels. So where these single bits would simply generate single pixels on a monochrome monitor, instead actually light up the equivalent of 2 pixels on a color monitor. And you can change the color by moving the pixels. So you can see here alternating this pixel will shift between green and violet. And 2 pixels next to each other will produce white. And so using combinations of 2 pixels, you can create these 4 color combinations. Now, this was the only 4 colors you could use in high-res mode on the original Apple II. However, an improvement was made on later revisions of the board that took advantage of this extra bit we talked about earlier, and now it controls the palette. So if this palette bit is set, then you can now make orange and blue within this 7-bit section. And so that gives us 2 additional colors, and with this setup, the Apple II can create 6 colors in high-res mode. However, one problem with this setup is that it's impossible to create certain colors next to each other. And if you attempt to display text in graphics mode, or using the lower 4 rows in a split screen mode, the text will appear rainbow color because now it will be forced to follow the same rules as the rest of the screen. And when graphics designed for color screens is displayed on monochrome screens, you wind up with these vertical line patterns instead of shades of gray. In fact, this is true even for the low-res graphics we talked about earlier, and you can clearly see each of the large pixels is made up of different vertical lines. One way to sort of sum up Apple II high-res graphics is to think of it like this. If you're connected to a monochrome monitor, then you'll get 280 by 192 pixels, and if you're connected to a color monitor, then you'll get 140 by 192 pixels with 6 colors. And this is all assuming that you lived in a country with NTSC video, because the color artifacting didn't work on PAL systems. So most Apple II users in PAL land simply got black and white only, unless they installed a special PAL video card in their computer, which had the circuitry to output color on that standard. Okay, so hopefully you have a basic understanding of how graphics work on the Apple II. Now let's talk about sound generation. So it was very innovative for Apple to put a programmable speaker into the computer when basically nobody else was doing that at the time. But after I show you how this works, I think you're going to see why that I classify the Apple II sound is basically the worst in the industry, at least the worst of any computers that actually have sound. Inside the Apple II is just a simple speaker, and if you read or write to memory address C030, it will produce a single click. It really doesn't matter what you read or write to the memory address. What causes the click is the CPU doing any sort of access to that address. So in BASIC, for example, you can type poke -16336, 0, and you'll hear a small click. Now, you might be wondering why you would poke to a negative number. This is a quirk of the original integer BASIC that shipped with the original Apple II, and you had to access the memory range. Instead of 0 to 65535, it would be -32767 through +32767. On later Apple IIs with AppleSoft BASIC, you could do a more straightforward poke 49200, and it would work just as well. You could also peek the address, and as you'll see, you'll get the same result. Now, what if you wanted to make an actual tone? Then you could make a loop like this. Of course, BASIC isn't very fast, so that's about the highest pitch tone you can make. There are some tricks, like maybe this, to speed it up a little bit, but ultimately if you wanted to make higher pitch tones, you'd have to do it in assembly language. This setup, while primitive, does allow making some creative sounds, and it's even possible to produce digital samples like this. But there are 2 huge problems with creating sound on the Apple II. The first is that the CPU has to do all the work to click the speaker. I mean, you can't just tell it to make a specific tone and then have the CPU go off and do something else while the speaker does its thing. Even on the IBM PC, a computer with relatively primitive sound, the CPU could at least tell the speaker to make a particular tone and then go do something else while the tone was playing. The second problem of making music on the Apple II is that the computer has no internal timers. Everything has to be done by counting CPU cycles, and this can be relatively difficult when you have multiple subroutines and you never know exactly how long it may take a particular subroutine to run. And so that makes it impossible to tell how much time has passed from one moment to the next, thus making a music with a steady tempo particularly difficult to do. And that's why the vast majority of Apple II games only play little sound effects here and there. And in most cases, the game actually stops during any sound playback. As long as the sound clips are very short, then the player usually won't notice this. Some games had some impressive intro music, such as Windwalker. But since the CPU had to do all of the heavy lifting to play this music, this means not much can be happening on the screen during this time, and such music was pretty much confined to the intro or the ending of a game. Of course, there would be improvements in both graphics and sound on the Apple II, and we'll talk more about those later in the episode, but for the moment, let's talk about expansion options. One of the great features of the Apple II was that it had 8 expansion slots. Now these could be used for, well, all sorts of things. And I'll start by showing one of the most important cards, the Disc 2 controller. So just so we're clear, this card didn't come out until 1978, a year after the Apple II had been on the market. So up to that point, the default way to load and save programs on the Apple II was to use a cassette recorder, like this. The slots on the Apple II are different from any other system of the time that I know of. The main thing that sets them apart is that each slot has a dedicated area in the memory map. And a peripheral card like this Disc 2 controller actually has 2 ROM chips on board. Typical cards had 256 bytes of ROM, and if you move the card to a different slot, then that ROM will appear at different addresses in the memory map. So I'm going to attach a disk drive to the card here. I'll attach it to the drive 1 position. Obviously, a second drive can attach here. These ribbon cables are connected directly to the drive and cannot be removed by the user. You can put the card in any slot, but I'll put it in slot 5. And then the cable can fit down into these little slots. And this smaller one here is just about the perfect size for the disk drive cable, so we'll use that one. If you were using one of these little security camera monitors, then the disk drive would usually fit perfectly to the side, like this. But if using a color monitor or television, then you'd probably set the drive over to the side, like this. Okay, let's boot up the computer. You'll immediately hear the sound of the drive headbanging. The reason for this is that Steve Wozniak chose not to use a head sensor to reduce cost, but one way around that was to simply retract the head 40 times at power up, thus ensuring the head would be in the correct place at each boot. Now, if you boot up the computer without a bootable disk in the drive, it will simply sit here at the Apple II logo. The code that is actually running at this point in time is the code stored on those proms on the disk controller. Its only real purpose is to find and run whatever code might be on the boot sector of a disk. The computer still has no DOS in the normal sense. So at this point you have 2 options. One option is to press Control Reset, which will abort the boot process and you can return to BASIC. The trouble is, since you didn't load any sort of DOS, you can't actually use any disk commands. As you can see, they just return a syntax error. So what you need is a bootable disk. Now, most software packages or games would simply boot directly without needing to load any sort of DOS first. But if you boot to a DOS disk, then you'll get the typical BASIC prompt. But now you'll be able to list a directory using the catalog command or use commands like load and save. There were actually multiple types of DOS for Apple II computers, the 2 most common being Apple DOS and ProDOS. But I'm not really going to get into the differences here. Another thing I wanted to show you real quick, if you do abort the boot process to BASIC, you can reinitialize the disk boot process by typing PR number 5 at the prompt. Now, I've seen some people claim that the PR stands for print output, where others say it stands for peripheral, which the second one makes more sense because all it does is tell the computer to run whatever ROM is stored in a card in slot number 5. And as you can see, it starts the boot process. Interestingly enough, if I move the card to slot number 3, I can type PR number 3, and again, the card will boot. There were a number of cards designed over the years. This is a serial card. This is a printer card. Here's a Microsoft Soft card, which has a Z80 processor on board so that you could run CP/M software. This is a sound card, which we'll circle back to, and this is an 80-column card, which we'll also circle back to shortly. But this is the one I want to talk about next, which is called a language card. The name can be confusing, and thus I really need to explain what this does. You see, the ROM originally contained integer BASIC, but as mentioned earlier, a lot of people upgraded their ROM to contain AppleSoft BASIC, a similar but different language. So what if you had software that needed the older version of BASIC to run? Well, you wouldn't want to swap the ROMs out all the time, so what the language card does is add another 12K of RAM here in this address area so that it can be switched or banked between the original ROM or RAM. In fact, it even adds another little 4K here that can also be banked, totaling 16K of RAM. So you could load in another language such as an older version of BASIC or even something like Pascal or Fortran. And the RAM can be write protected if you want, therefore making it behave very much like ROM. And so that's what the language card was originally intended for, hence the name. However, as more time went by, it simply began to be used more and more as a way to just add more RAM to the computer, to boost it up to 64K. So much so that a lot of games eventually started requiring 64K in order to work. In fact, even ProDOS requires 64K. And thus, by the year 1980, the Apple II quickly standardized on 64K and a floppy disk drive, with virtually all commercial software being sold on floppy disk instead of cassette tapes. As time marched on into the 1980s, the Apple II was becoming less and less competitive with other computers, especially in terms of graphics and sound. In 1981, Apple introduced the Apple III computer, which was supposed to replace the Apple II. It did have more advanced graphics, but this computer was a massive flop in the marketplace, and thus Apple refocused on the Apple II line instead. We'll revisit this computer in a later episode as it's too much to cover here. So back to the Apple II. One issue with improving the sound had to do with another company by the name of Apple Corps, which was a music company owned by the Beatles at the time. And the problem is Apple Computer had already experienced some legal trouble from Apple Corps, which resulted in a settlement where Apple agreed never to enter the music business. And so, as you might imagine, Apple was hesitant to improve the sound system of the Apple II. Now, you might think that adding better sound capabilities to a computer could hardly be considered entering the music business, but they did indeed get sued again in 1987 for adding a music synthesizer chip to the Apple IIgs, which is a topic for another day, but nevertheless it illustrates that the threat was real. Of course, the Apple II had expansion slots, and anyone was capable of making expansion boards, so in 1983, a third-party company did indeed create a sound card called the Mockingboard, which is the closest thing the Apple II platform ever got to a standardized sound card. The Mockingboard used either one or two AY3 sound chips, which offered either 3 or 6 voices. The card also contained 6522 control chips, which also added several internal timers to the system, which were also badly needed to make proper music. And while the sound was considerably better than the internal speaker on the Apple II, it was still somewhat inferior to sound offerings by Atari and Commodore, since the Mockingboard was limited mostly to making square waves. The worst part is, software support for the card was rather weak, and there were only about 50 software titles that supported it. And most of these were, of course, games, but there were also some other musical-oriented applications as well. And of this very short list of supported titles, 4 of these are actually modern games made within the last couple of years. Okay, so it was possible to improve the audio on the Apple II, but what about video? Well, the best way to improve that was with an 80-column card. There were both third-party cards and official Apple II cards. Now, these cards essentially doubled the horizontal text resolution to 80 columns, which was immediately usable in BASIC by typing PR number 3, or whatever slot the card was in. Crisp 80-column text became very important for business applications and even terminal programs. Also in 1983, with the Apple III not doing well, Apple released the IIe. The E is supposed to mean enhanced. This computer came standard with 64K, basically integrating the language card internally, and there was a special slot that could accommodate this upgrade card, which would add 80 columns and 64 additional kilobytes of RAM. That way the Apple IIe could have 128K. Visually, it looks very similar to the 2 and the 2 Plus, but there are a few visual differences, such as the power light and an overall much better keyboard. 2 modifier keys have been added, what we call the Open Apple and Closed Apple keys. Interestingly enough, these keys are not electrically part of the keyboard, rather they map to the joystick buttons 0 and 1. You also now have 4 cursor keys, although they are arranged in a way that nobody would ever use them. You also get things like a caps lock key, a tab key, and a delete key. Although the delete key is somewhat infuriating as it doesn't work, at least not in BASIC. I've never really understood why it was done this way, but you were still expected to use the left cursor key to correct mistakes. And if you instinctively tap the delete key after making a typo, not only will it not correct it, it actually makes it worse. Fortunately, the key does work correctly in some productivity software like AppleWorks. The rear of the Apple IIe is also quite a bit different from its predecessor. The vertical slots are gone, and now there are these various empty port slots with removable covers. So, for example, if you had a card that needed to have a port on the outside world, you could just simply remove one of these empty covers and then add your port. The Disk 2 controller also had the option to mount in one of these holes as well. The new disk drive was far more elegant design and used a D-sub connector rather than the ribbon cable. You also get a joystick port on the rear, which does require a different connector than the previous joystick. The 80-column card in the IIe didn't just double the text resolution, it also doubled the graphics resolution too. So now you can display 560 by 192 monochrome bitmap resolution. But if using a color monitor, the resolution essentially stayed 140 by 192. However, because of the quirky way color is produced, you can now display 16 colors instead of 6.
The trouble is, the Apple II base graphics was still the standard. That's what the software companies wanted to support because that would give them the widest audience for their software. It's a all too common problem in the computer industry, and we kind of call it the chicken and the egg problem.
Of course, there were a few programs that supported 80 columns, such as AppleWorks. And for graphics, DazzleDraw offered support for the improved graphics modes. But I don't think it was until the 21st century that we were able to see the true capabilities of the new graphics modes, thanks to modern conversion algorithms that can automatically convert a photo to the double high-res graphics. These are actually quite impressive. Oh, and it wasn't just the high-res graphics, but low-res also got doubled to 80 by 48. And here's a modern game, a version of Angry Birds, that actually runs in this mode. Another game that uses it is Pensky Robots. The regular game screen runs in the standard 6-color graphics mode, but when you press tab to get the map, it uses double low-res graphics for that, which means you do have to have an 80-column card to use the map. Around this time, Apple started producing its own line of monitors, such as the Monochrome Monitor 2. This was meant to be both the affordable option as well as the sharper monitor for displaying text. So if you're a business and you only cared about text applications, this would be the perfect monitor since the Apple II couldn't display color in text mode anyway. Now, one neat feature of this monitor is that the CRT can pivot inside the case for different viewing angles. The other monitor would be the Apple Color Monitor 2E, and this would be the high-end option, and obviously it displays color. However, due to the quirks of how Apple's video system worked, it also has a button to kill the color signal. That way, if you're trying to use a program that needs high-res graphics but is supposed to be monochrome, then you can switch to that mode for sharper monochrome graphics. Not long after the 2E came the 2C. The C stands for compact. And compact it was, compared to the 2E, and you'll see exactly what I mean. In fact, this isn't even a fair comparison because the 2E doesn't have a disk drive here and the 2C does. The 2C was a very elegant design with a disk drive on the side, and the carry handle could double as a stand if you wanted a different typing angle. Apple also offered a small matching monochrome monitor and even a flat panel display that could sit on top, making this a truly portable system. It wasn't necessarily cheap, starting at $1,290, however it had quite a bit of hardware built in. Besides the obvious disk drive, it also included 128K of RAM, serial ports, and 80-column capability. Of course, there were no internal expansion slots. However, from a software perspective, everything had to be assigned to a port, and so this is how they ended up. In fact, by this point in history, this arrangement had become somewhat standardized on the entire Apple II line because certain software started to expect things to be in certain slots. The Apple IIc really deserves a video of its own, as there's a lot to cover on this little guy, and we'll get to that someday, but for the moment, let's move on. The next product in the Apple II line was the 2E Enhanced, which is sort of a strange name because the E in 2E was already supposed to be an enhanced, so a 2E Enhanced would be an enhanced? Anyway, what I have here is actually a later model called the Platinum, which has a slightly different color scheme and a number pad. These came standard with 128K and 80-column cards. Okay, so I want to compare the keyboards of these machines right quick. So first of all, I just want to let you listen to the different way that they sound. So the Apple II and II Plus keyboards are actually pretty terrible. I got to be honest about that. The keys they're very squishy, and they can even bind up if you don't push them like at exactly the right angle. And honestly, I can't get more than about 20, maybe 25 words a minute typing on a keyboard like this, and I make a lot of mistakes too. Now moving over to the Apple IIe, I'm not quite sure what they did, but the keys are significantly better. They're still a little squishy, but they have a nice hard stop to them, and they don't bind up. So I can do 40 words a minute or more on a keyboard like this. And then the 2E Enhanced, this one is the absolute best keyboard. I can type pretty fast, probably 50, 60 words a minute without making too many mistakes on a keyboard like this. It's just way better. It was around this time that Apple also introduced the 2GS, which is actually a 16-bit computer, and there's so much to talk about on this, I think it should also be its own video, so we'll come back to this later. The last computer I'm going to show you in this episode is the 2C Plus, which came out in 1988. It's an enhanced version of the 2C, and obviously the colors were updated to match the platinum look of the 2E. The 2C Plus has a much better keyboard. Although it looks the same, the Plus feels much better to type on. Also, the disk drive was changed to a 3.5, which is sort of weird since very little software was produced for the Apple II on these disks. The computer could also run at 1 or 4 megahertz, making it the fastest of the 8-bit Apple II line.
Okay, so now that I've shown you all the different Apple II computers, let's talk for a moment about the Apple II's role in the computer industry during the later 1980s. So as a computer for playing home video games, the Apple II had fallen quite a bit behind other computers like the Commodore or the Amiga or the Tandy or any of the IBM PC compatibles.
Those computers were often cheaper, they were more visible being sold in regular electronics retailers, and honestly, they just had better graphics and sound. But where Apple continued to do well is in the business market. At that time, things like crisp 80-column text, fast disk access, and 128K of RAM is what mattered when a business was interested in running a word processor, a spreadsheet, or database. They didn't really care about graphics and sound so much. An Apple II was a far better choice for this type of thing than, say, a Commodore 64. Another place Apple continued to do well was in the education market. Remember earlier in the episode when I talked about the Apple II systems in my school and how I couldn't believe they would pay those sort of prices? Well, it turns out that Apple actually gave away a lot of free computers to school systems in order to entice them into buying more later. This was accomplished through their Kids Can't Wait program. There were also attempts to pass government legislation like HR 5573 or the Computer Equipment Contribution Act, otherwise known as the Apple Bill. Now, while this bill passed the House, it never passed the Senate. But there were other smaller versions of this in states that did help Apple get tax credits for giving away computers to school districts. And to top it off, here's an official price list from 1987 showing what schools would pay if they chose to buy more computers from Apple. For example, in a large purchase, a school district might be paying as little as $736 for a complete Apple IIe system with disk drive and monitor, which at that price was fairly competitive with offerings from Commodore. And of course, by the mid-1980s, a school system would probably also have invested heavily into Apple II compatible educational software, so changing platforms wouldn't be a wise move either.
In fact, these Apple II systems continued to be used well into the late 1990s, and the reason was simple. I'll give you my high school as an excellent example. So in the mid-1980s, they had replaced all of the Apple IIs in the computer labs with Macintoshes and even some IBM PCs. But they still had all of these Apple IIs. So basically any teacher that wanted to have an Apple II or even a few Apple IIs in their classroom could have one. I mean, like, why not? I mean, they have them. They're not going to get rid of them. So they might as well use them for something. A great example was my German teacher continued to use them throughout the 90s because he had some German vocabulary software that little games you could play to help you learn German vocabulary. And I mean, like, why not? I mean, it still worked and it was still relevant and it still did what it was supposed to do. So why not use them?
The last Apple IIe was produced in 1993, also the year I graduated high school, but that wasn't quite the end. Apple also produced something called the Apple IIe card, which could be added inside of certain Macintosh computers. And since it was basically a real Apple II on the card and not just some emulation, many people consider this to be the last Apple II made, and it continued to be produced until the year 1995, meaning the Apple II was in production in some form or another for close to 19 years. Apple II computers have been featured in more movies than I can even count. I mean, just look at this list. So I'll show you some of my favorite movies. The Apple IIc was used in The Explorers, as well as 2010, the year we made contact. Apple IIes are shown many times in Young Sheldon, and a standard Apple II can be seen in the movie Spies Like Us.
And that about wraps it up for this very long history episode. So I do plan to come back in the future and cover in more detail the Apple IIc, the Apple III, and of course the Apple II GS. But that's all for now, so as always, thanks for watching.